So yesterday we looked into tracing tensor subclass with export in pre-dispatch mode. And I think one issue we ran into was pre-dispatch mode doesn't handle custom user-defined part dispatch modes. It only handles like functional tensor mode and proxy tensor mode. And that's why it doesn't work today. So I think we need to extend pre-dispatch mode handling to handle user-defined tort dispatch modes. And I guess there are two ways to do it. One is we piggyback on like Python key target dispatch mode handling. Uh, Ed.
Oh, I have some basic questions, but you can finish your explanation first.
And then so the one solution is like we just extend the Python key mode stack handling in C++ to pre-dispatch mode. Other one is like we special case nested jagged tensor to always run before like our functional and proxy tensor mode.
Okay, so some basic questions to help set the scene. So question one is which uh, which tensor subclasses slash torch dispatch modes are we concretely talking about here?
Nested jagged tensor?
Nested Jaga tensor. That's it.
For now, yes, yeah.
Okay, for now. Okay. Question two. You said torch dispatch mode. Did you really mean that? Because nested Jaga tensor doesn't have a torch dispatch mode.
Oh, so like nested jagged tensor has like a custom torch dispatch,
Yeah,
like
so
function.
it's got a torch dispatch on the tensor subclass, but it doesn't have a torch dispatch mode.
Right. Yeah.
Okay, so just a slight me being pedantic, but just to set things. The third question is so you talked about non-strict export. Does this all work in Dynamo? Strict export?
No, it doesn't. It runs into other problems when it's facing with Dynamo.
Okay, so our hypothesis. So you frame this as specifically non-strict. So is this just
Yes.
because the prod models are going down the non-strict path, and so that's the one that's important right now?
Yeah.
Okay, Brian, go for it.
Oh, I think this is also me being pedantic, but I think so. Nested Jaga tensor has both a torch function and a torch dispatch. And for pre-dispatch export, we don't actually want to trace inside the torch dispatch implementation. And so, I think, isn't the specific problem that it's just for torch function? Like NJT has a torch function implementation, and pre-dispatch tracing relies on a torch function mode. And it is set up today such that we end up running the pre-dispatch export torch function mode before we run NJT's torch function.
Uh, so I thought NGT has both like torch dispatch and torch function. Are you
I think it
saying
has both. But for pre-dispatch export, I would expect us to trace through the torch function, but not to trace inside the torch dispatch.
why is that?
Um, like for pre-dispatch IR, we're not tracing like normal tracing for like tracing through AOT autograph will trace inside of torch dispatch tensor subclasses. And then the result of a graph when you run through AOT autograph is that there's like fully no tensor subclasses anywhere. We trace through everything. But for pre-dispatch IR and pre-dispatch export, I would basically expect that everything above the pre-dispatch level is traced into, but everything below the pre-dispatch level is not traced into. And in this case, like torch function is a thing above the pre-dispatch level, and torch dispatch is a thing below the pre-dispatch level.
I see.
Wait,
Uh,
sorry, to clarify, like,
go ahead.
do you want to like get rid of the NJTs when you're tracing through them or no?
I
Like
don't think
if
you want to
the
get rid of the
result,
NJTs, but I think you do want to inline just the torch function piece of the NJT.
right, I want to clarify, I guess, like what like Tugzu and Sherlock want.
So I think we want, it's unclear which level of IR we want. According to the default export, we want to first have a pre-dispatch graph and then have the freedom to do some kind of transformation on it. But later we want to re-export again and lower it to post-dispatch IR. And at that place, we're going to get rid of all the NJT. And then the downstream compiler and runtime and serialization doesn't need to handle the subclass nets. But so far, like what I have understand is we still want a stage in the pre-dispatch IR.
Where like NJTs still exist in the graph.
Correct.
Okay, cool. Makes sense.
Okay, I have a similar question to Horace's, which is, can anyone show me like what you guys like at a very high level what you want the graph to look like after pre-dispatch export? Like, do we have any like sample code? It's like, oh yeah, you know, this is what I'm expecting to see. I want to see a, you know, NJT input to the graph, or I want to see these operations. And I also want to know more details about what NJT is using torch function mode for. Because Brian was saying things about, oh, I was expecting you to have inline through torch function, but I don't understand. Like, I actually don't know.
Oh, I can I can talk to what it's using torch function for. So SDPA is like the most important op for NJT, and we have to kind of implement our own backend selection logic for that. And right now, the way to do that is through torch function. And as far as I know, there's no way to do that on the torch dispatch side.
Is it because SDPA is a composite implicit autograd op?
Yes, that's right. Yeah.
Okay.
And it's literally only that.
Yeah, I've had this discussion with Driss about can we make it composite explicit, and there's reasons why. Maybe he can give a better background to that.
Sure,
But yeah, anywhere like
us.
for SDPA and also for other things that are composite implicit where we want to override the decomp and provide our own. So I think the other example is flatten.
But I just want to confirm that in principle, we are able to override composite implicit autograds without using torch function in the compiler stack by using the Python dispatcher. Like, we do this a few places. So for me, it's like this may not actually be what we need to do here, but I just want to confirm that there isn't anything blocking us from doing that strategy.
I'm not familiar with how that would look. My understanding is that if it's composite implicit and we need to provide a custom decomp, we need a torch function.
No,
so if there's
you can also PyImpl it, and that lets you override the composite entirely.
Okay, well,
but that would be for torch compile only.
Yeah,
I think Joel
torch
cares
compile
about
only, and you'd have to like do more stuff. Well, but non-strict export can also like turn on the Python dispatcher and like make use of those overrides as well. But for eager mode, yes, you have.
Okay, for eager mode, yeah.
Wait, but is there a problem, Joel, in eager mode?
We do have the problem in eager mode also, yeah.
No,
So
but I guess, is it a problem in eager mode using torch function?
No, I don't think so.
Okay, there are some questions queued up. Sorry, hands. David.
For like sigmoid export stuff, I don't think, well, like I think it's fine if pre-dispatch IR doesn't have NJTs, right? Like I thought the reason we care about it is so that we have like you know, pre-autograd IR. Is that right?
Oh, sorry, can you say again?
Like isn't it okay if pre-dispatch IR has like does or doesn't have NJTs? Like
no, I think
like
in pre-dispatch we want to have NJT in it, and in post-dispatch we'll remove it.
I thought like the whole I thought like we care about like pre-dispatch because we don't want like we want like pre-autograd, but I like is there a reason we care whether we have like subclasses?
Or I think the problem is that like normally if you think about the normal stack with autograd, the way it runs is I guess like torch function, torch function stuff, you know, autograd, then NJT torch dispatch. And so
Right, okay.
the NJT torch dispatch is the point at which the NJT disappears. And so you can't run, or at least it seems difficult to me to run like the NJT torch dispatch and then run autograd and make sure that that also still gives you way more.
Unless you rewrite NJT as a entirely torch function tensor.
Yeah.
Taksu.
Yeah, so this reminds me, like it might be too technical, but So if we don't handle torque dispatch mode for custom tensor subclasses, the problem now will be that the functional tensor, like our infra subclass tensor in torque dispatch mode, we will receive like custom tensor subclasses, right? So there it's like it's kind of unclear how we can handle it directly. Like in functional tensor, we would expect to see like a bunch of functional tensor arguments, right? But now we will receive like user-defined tensor subclass. So is it just safe to like unwrap it and then trace it and put it back, or
All right.
then
Okay, so there are a few ways we can take this discussion, but I think the most important one is to talk a little bit more about expectation management for what export is getting after pre-dispatch with tensor subclasses. And this is exactly Tuksu's question. So no one volunteered to tell me what exactly the graph they want was. So I'm going to tell you what you're going to get. I'm going to ignore the torch function issue for now, although that's the reason why we're having this discussion. I don't want to deal with that right now. So, okay. Hang on. Okay, so here's what I imagine you're going to get, right? Okay, question. Are we getting any NJTs as inputs?
Nope. This
No.
is generated in the middle of a module
Generated
at the moment.
Okay, so you got some model. I don't care what the inputs are. Are we calling like a constructor to generate them or what?
Yes, we are calling a nested tensor constructor
Okay.
to.
So what you're expecting to get in the exported model is you're going to see literally the construct NJT function with whatever arguments there were on it. And this is pre-dispatch. So this is not going to be torch.construct NJT, but it's going to be torch.ops.a10.construct NJT. Joel, do you want to give me the real function or correct me here?
I could, but I just wanted to mention, I think for future production models, it is like important to think about the NJT input case also. I don't know if that changes this a lot.
No, I don't think it matters too much, but I just wanted to figure it out for the question.
So the real one is
yeah, the input basically just opens up more problems, but everything you see here, you also have to deal with. Okay, so you'll see an op that constructs an NJT. This is going to take some tensors, and it's going to give you a NJT on the inside. And then you'll see some other operations directly operating on the NJT, like maybe say a broadcasted edition. And then eventually you'll see, something that like I don't know, NJT values or something, or like sum or something. Yeah, sure. Something like this. And this is what I'm expecting to see in the graph that you export. Okay? So let's walk through some implications. So implication 1. I assume that export needs to somehow ingest this graph later, right? So what does the ingestion pipeline look like after you've exported a pre-dispatch IR? Like, how do you actually like get it back into an FX graph in memory?
Later, we're gonna lower this to post-dispatch IR. So
Yeah,
there's
so
gonna
what
be a
exactly does
graph
that
passes
lowering
that
pipeline look like?
it's gonna be another ALT export and then set the flag to post-dispatch. So basically, it will retrace through this graph.
Okay, and when I call AOT export, this is going to be in a fully fledged PyTorch environment, and in particular, like functions like construct NJT will exist, and they will return NJTs. Okay, so this seems fine. Any questions or comments? Okay, Brian?
One question I had that I talked to Sherlock a little bit about earlier this week was how important is it for people consuming the pre-dispatch export graph to be able to see the metadata on the nodes of the pre-dispatch graph? Where like one annoying thing that probably doesn't work today is the metadata on each of those nodes will be a NJT tensor subclass whose inner tensor is a fake tensor. And I doubt that we serialize that properly today. And like we could, but that would be extra work.
I'll answer this question. If they're using AOT export, it doesn't matter because like you don't need a FX graph with metadata on it to AOT export it, right? AOT export
Yeah, I
will
think
do the
it's.
computation.
I guess I imagine it would only matter if there's people who want to like interpose on the pre-dispatch graph before calling AOT export, and then like do a graph pass that needs the metadata. And maybe that's not really a use case, but
No, because AOT export is how they're actually getting a graph. Because what the okay, just to confirm, the serialization format is just going to be some blob of Python code. Am I right?
No, like
No.
I am
Okay, tell me
not
what the
even sure that
serialization
we.
format is.
Okay, like first of all, I'm not sure we want to serialize this graph, but I can tell you why I think like somewhere in the stack, maybe people want pre-dispatch IR. One case that I can think of is inductor passive. All the inductor passes are implemented targeting pre-dispatch IR. So if you like lower it to post-dispatch, those passes will fail. So I think inductor will want a pre-dispatch graph. But like if we were to do the export and inductor compilation in two different machines, which it is currently a production constraint, then this will require us serializing the pre-dispatch graph. The pre-dispatch graph, if we have to serialize it, then it has to be serializing using the internal like Swift structure and then package into the PT2 archive. So it's going to be like a serialized graph, which with nodes of target like that construct the NJT, and then have some like just like this graph.
Okay,
But we will
so
need to add additional support for NJT
that is
metadata.
fine, but okay, so imagine you serialize it to thrift, and then you deserialize the thrift. So you have a bunch of, you have a bunch of thrift structs. You still need to turn it into an FX graph. So how are you going to turn it into an FX graph?
We have a deserializer.
Yeah, but
that goes from Swift
concretely,
to
what does the deserializer do? I can give some like straw proposals.
So like it's going from the target, which is a string, back to the actual Python function or Python method. So concretely, what we're doing is to go through the module attributes and then get that function pointer.
So essentially, you're saying that we'll take the thrift structure and then we will like sort of iterate over it, and like for each node, create an FX node resolving the Python strings into the actual Python callables.
Yep.
Okay, this seems reasonable to me. So Brian, to answer your question, if they're willing to do fake tensor prop during this process, then they can reconstruct the metas that way.
that makes sense. So concretely, like we wouldn't serialize the meta, but anyone who wants to do things would need to deserialize, run fake tensor prop themselves to get the meta. And then
there is one thing they do have to do is they have to save fake tensors for all the inputs. And if there are NJTs in the inputs, they have to save fake tensors for that. I'm not entirely sure how that's going to work. But you do need these inputs one way or another. I don't think there's any deserialization strategy that lets you get out of not having those. So we can unpack that some more, or we can just trust that this is a solvable problem.
Does this mean we have to serialize view functions?
Well, because this is inference, and because we're probably not going to let people pass in views that we're going to mutate and all that stuff, you probably can get away with a simplified format. Yes, if you wanted to embed into like a full like on everything disaster is supported situation, then you would need indeed to serialize a lot of things. But you can simplify it this way. But also I wrote a like serialization format for fake tensor, which is perfectly faithful. So you can also use that too. Okay, so let's talk about torch function. I'm going to do SDPA because that one is the most prominent. So the main question I have is, so are you excited to see SDPA in this graph?
Yes. We're going to see njt.view and then SDPA.
Okay. Well, this isn't going to work, right? Well, I mean, I don't know if I'm getting you SDPA in the graph if you guys torch functioned it.
Well, okay, I probably misspoke. Like, I think it would get the actual backend selected function, like flash attention in the graph. But
so do you want backend selection to have occurred all during export or during optimization? I think that's the important question.
Sounds like conceptually you do want the higher level SDPA here.
yeah, because backend selection is data dependent, and you want to defer that to backend
so then I have a very simple fix for you guys, which is instead of us talking about torch function, mode ordering, whatever, just get rid of the NJT torch function and put some if statements in the regular SDPA composite dispatch and call it a day.
Oh man.
Driss, how mad are you at me for proposing this?
I don't know, medium mad.
There's already a bunch of nasty nested logic there for old nested tensor. So it's hard to do both.
Yeah. That's my main qualm. It's just piling on, but I don't know.
What else are you gonna do? I mean, my PyImpl proposal is the same thing, just like you have some action at a distance where you're post facto adding some extra logic on. Brian,
Wait, sir, why does torch function not work?
Because I don't have an A10 op. Well, I mean, so pre-dispatch IR, we do want everything to be like these normalized things with schema, right?
Yes, and then I don't think we have a constructor at this moment. I see two ops. There's like dense to nested and then jagged to nested. They are not A10 ops per se, they're just functions. And under the hood, they call nested tensor constructor.
Those should be, well, actually, I'll sync with you offline, but that should change, I think, to use our actual op.
Oh, also, okay. If we have a real
Joel,
A10
this
op,
is why months ago,
Yeah.
was it you or someone else was like, how do I return a tensor subclass from an A10 op, right? And then we eventually unblocked y'all on that.
Yeah.
Right? Yeah.
That's right. So yeah, the new API for constructing NJTs will just be like a single op.
Okay. Does anyone want to do a counter proposal? Like what?
I was just gonna say, in theory, we need general tensor subclass constructor support in pre-dispatch IR if we care about exporting all the things and maybe other subclasses that are not NJT could be in pre-dispatch.
No, I want to force everyone to make A10 ops for the export case.
Custom ops
also seems reasonable.
Yeah, it can be a custom op. It doesn't have to be in native functions.yaml. You can use Richard's fancy new custom op API to define these.
schematized custom op.
Exactly.
Yeah, I agree.
Right, actually, I'm confused. Is the issue here that we don't have a pre-dispatch towards dispatch?
So concretely, basically the reason why we're here is because there's no way for NJT to override SDPA. So yes, in some sense, not having a pre-dispatch torch dispatch is the problem.
One like SDPA can in theory be made non-composite. And I have the doc somewhere on doing that. It's non-zero amount of work, but I think it could be done.
And that's bringing all the like lower level backend args up to the main SDPA signature,
Um,
or is it different?
yeah, I think it was that one, which sucks, but yeah.
By the way, Driss, another reason why you might want to make. Wait, hang on. Is your problem that the autograd formulas vary depending on the backend?
Part of it.
That's part of it, yeah.
But this is like, but we're talking about inference, right? Or not?
I mean, the main like trickiness was just that there's the math backend, which is composite implicit, and so like the backends are all like their own dispatch and have their own derivatives registered. But like one of the possible choices from the top level SCPA is the math backend, which is composite implicit. I mean, I just wrote like the backwards formula for flex attention, so like we can definitely write the backward, make it composite explicit. Um,
Yeah. So
but there was this weird like
one reason
yeah.
to have SDPA without backend arguments or weirdness as a non-composite is it makes it so that you can actually have it in the graph, so people can like pattern match against it.
I think that is a very strong argument that has been made, and like I totally agree with. I think having to register dispatch implementations for like multiple STP ops is gross. So I get it.
Sorry, Horace, did you have any more thoughts? Because I also agree with you that if we have pre-dispatch, torch dispatch, you can also solve this problem that way.
I guess I would also say that like I think the like needing to like duplicate like the nested tensor dispatching, like I guess for flex attention or something like that, you'd also need to duplicate it again, and actually maybe it's better in that case, but yeah, like I do sympathize with Chris that it kind of feels bad to like put the nested tensor dispatch logic within the op itself.
Okay, so there's like other things you can do. So like this is not the first time it's been like, oh, we have a composite operator, but like I need sensitive subclasses to be able to override the behavior, right? So which off is it? I don't even remember. But we did a thing for XLA where essentially if the thing is like not a normal tensor or it's like a Python subclass, then we call in the composite we call a different op, and that different op is not composite and can be overridden. And so basically, if you fed an NJT to SDPA, it goes to this other like I don't remember. Does anyone here remember which op this is? Brian, does this ring a bell?
That does not ring a bell. Is that for XLA or something else?
Yeah, I think it was like for
XLA.
XLA.
XLA might have done it for max pool to the.
Anyway.
Are they like
convolution?
Yeah, maybe it's convolution, like generic convolution. Convolution generic.
Yeah, it's convolution. We override to a convolution overridable.
By the way, there is a PR to add a SDPA overridable. Drace, I think Drace, you tag there.
Okay, convolution's a bad example though, because Joel suffered for us to like turn convolution into a composite explicit autograd. So like this thing doesn't exist anymore. Like it's a historical way we had it while convolution was still implicit autograd. It's convolution overridable, by the way.
Yeah. In a non-compile world, torch function is the solution, right?
No, not necessarily.
Okay.
Also, if we're talking about moving towards full torch function implementation of NJT, wouldn't that just make the problem worse?
So in a full torch function implementation of NJT, you would not see NJT in the pre-dispatch IR. So that's either good or bad. Certainly, if you need the dispatch decision to be delayed, then that's bad. But I don't want to talk too much about this because this doesn't even exist. So like, We can talk about it when it exists. Taksu?
Yeah, so I'm a little bit confused. So when we say we want to support pre-dispatch, toward dispatch, does it mean that we're gonna unwrap the tensor subclass before our infra subclasses, or I don't understand what do you mean by like we support toward dispatch, pre-dispatch, toward dispatch here?
So the what Horace was referring to with pre-dispatch torch dispatch is right now you write torch dispatch, and you only get to this function after all the composite implicit autograd decomposition have run.
Right.
So there would be a way to write a torch pre-dispatch magic
Oh,
method,
I see.
which you get what gets called before the autograd stuff gets done, but it's still you're still getting torch.ops.a10 stuff.
I see.
And you actually have you can either choose to decompose or not in pre-dispatch export. You probably don't want to decompose in pre-dispatch export, so you don't want to run these before you've run pre-dispatch export.
I see.
Okay, can we? Do people know what to do?
So in pre-dispatch export, right, when we receive user-defined subclass, is it safe to unwrap it and just put it back after we do our stuff?
In pre-dispatch export, is it safe to unwrap before we do our stuff? I don't understand the question.
Like if you receive nested jagged tensor in functional tensor, is it safe to just unwrap that? And
I think you wouldn't want to unwrap. Like you would. Sorry.
I feel
Actually,
like
no,
there's
I'm
some
not
mechanical problem that I don't understand right now that Taksu knows about because he's trying to code it. Taksu, do you believe me if I say if we do something different to how SDPA torch function is implemented in NJT, this solves your problem? Like, as
so
in,
we don't.
the code you're exercising doesn't get exercised anymore.
So you mean like, so when we like pre-dispatch, let's say, so as long as we see a nested jagged tensor, then this is a problem, right? And when you at the torch dispatch level.
Sherlock, go for it.
Oh, I want to backtrack and then attack this from a completely different angle. I want to ask, what is the real value of having pre-dispatch ops for tensor subclasses? Because I'm thinking about, like, because I tried post-dispatch for NJT and it actually exports. So, like, if we can have an export that would have regions of the graph in pre-dispatch and then the other region in post-dispatch, I think we would just avoid this class of problem in all. Like for example, like the reason why inductor needed in pre-dispatch IR is for the A10 dot linear, right? It's not because I don't know whether it's because it's there because we need A10 dot SDPA kind of thing. So basically, you can mark a module, for example, the multi-headed attention module, which uses nested tensor under the hood, and say, for this particular module, when you trace it, let's just use post-dispatch. It has tensor subclass in it. It's just a can of one. Let's bypass pre-dispatch. For that module, just always use post-dispatch. And for the remaining, we still have pre-dispatch. So it goes back to like, does inductor need nested tensor in pre-dispatch? What's the value of like having a pre-dispatch operators for inductor?
I think it probably depends on the inductor passes. Like if the inductor pass expects NJT to be a concept in that graph and requires it, then it wouldn't work otherwise. I don't know.
Yeah, like does it accept NJT?
I don't actually know
They-
what classes are being run in practice, because that'd be useful to
I'm
know.
pretty sure we do not have any NJT passes, FX passes. Does anyone want to correct me on this? Oh,
Yeah,
David.
I'd probably say we don't have any, as far as I know.
But we are talking about like the higher order op stuff for reductions, right? So, but that should be fine, right?
Higher order ops is its own problem, which we have
Okay.
not talked about at all.
Oh yeah.
Okay, can I reiterate my suggested plan of attack? My suggested plan of attack is stop torch functioning NJT and do something to the SDPA operator so that you're able to change the behavior, okay? So it can be bashing in the thing directly, which no one likes. It can be adding a SDPA overridable, which then is not composite anymore, and therefore you can call it. You can override it from NJT. It could be making SDPA entirely non-composite. It could be, in fact, what if you just implement an MHA operator which contains the subclass stuff, and you export that all in one go. But that's essentially like, the area solution space that I think is like the most practical to pursue.
What about the other like non-SDPA options? Like flatten is an example, and I'm sure there's others where because of some shape nonsense, we have to provide a different decomp for NJT.
Or
Same strategy.
why don't you like just running torch function before the pre-dispatch tracing? Or like that was like the initial issue here, right? It's like they want to run the torch function, the tensor subclass is torch function before the pre-dispatch tracing, and that's not working today. But I guess to me morally that seems fine. Am I misunderstanding something here?
David, go for it.
Yeah, sorry, but I think Tuxu was saying this, but like my understanding is that the torch function issue is not actually like whether we run torch function is not going to affect the issue that we're running into, which is that like other infra passes or other infra modes are like not handling NJTs correctly. And as long as we're in pre-dispatch and not tracing through the NJT torch dispatch, we're still going to run into that issue.
Sorry, what are the other modes that don't handle NGT?
Oh, this is Tugsu's thing where he's like, if I have an NJT to a functional tensor, what do I do? Which I didn't understand.
Where this
This
functional
might
tensor,
be. Oh, sorry.
sorry, like this functional tensor is like the pre-dispatch functional tensor.
I guess my understanding is that normally when you're running like AOT inductor, you're gonna use the functional tensor like after torch dispatch, but in pre-dispatch tracing, you're trying to run it on like before torch dispatch, before the subclasses run torch dispatch.
Yeah, I think that's right. Like today, normally when you run in normal torch.compile without pre-dispatch, when you have subclasses of functionalization, we run functionalization underneath the subclass. And so we end up with like NJT, whose inner tensor is a functional tensor holding values offsets. And then for pre-dispatch, I guess we want to do the opposite, where we want a functional tensor that holds an NJT. If we're saying we want to run functionalization without desugaring subclasses.
Wait, sorry,
So-
have you been talking about two different problems? Like the SDP is the SDPA problem related to this problem at all, or are these two completely independent issues?
I think they're independent, but I could be wrong.
I feel like they're independent, but one might affect the other one. If we have a functional tensor holding an entity, then that might make it harder to inline the torch function.
Just to clarify, we're talking about pre-dispatch functionalization. Is that right?
Yeah.
Yeah.
Okay, Horace, to answer your question, we can also solve it by like having some sort of torch function mode infra thing, fixed ordering. If Brian's willing to implement it, like that's fine too. Is it hard, Brian?
Does that actually fix the issue?
No, it doesn't fix the second issue, which we have only just got into. It fixes the SDPA issue.
Yeah,
but only if you're okay with backend selection happening at export time. I think the reason why I'm trying to get people to not do this is because I don't think you want backend selection to happen at export time. Like my experience with this is just like, I just wanted an A10 linear. Why are you decomposing it? That's my experience with this.
Yeah, I also think if we want functionalization to run before NJT during pre-dispatch export, I think it might be easier to do that too, to not have the backend selection happen at export time.
Okay, I don't know if we're all chatted out or if we want to try to tackle this other problem. Okay, Tugsu, can you try to describe to us what the general strategy for pre-dispatch functionalization with tensor subclasses is? At a high level.
So my understanding, after Brian just spoke, I think maybe we just wrap the nested jagged tensor with functional tensor and then just functionalize it that way. So it's kind of like all the way around then post-dispatch functionalization.
Yeah, that seems like the right thing to do. I don't know if it'll work, but like it's certainly the first thing to try.
Yeah.
Does that solve your problem?
I think so, yes.
Okay. I don't know what people are planning to do, but if you can like post in the chat or on the page like what folks are planning to do post this discussion, that would be very helpful. Okay, I'm closing this topic. Oh, we don't have a lot of time. Michaela, tell us about weights only. I think we can squeeze that in.
Where is that?
Do we have it, Michaela?
Yes.
Okay.
Okay, so what is the problem? The problem is torch.load uses the default unpickler, and this is very unrestricted. Based on what's in what it's loading, it can import like any module, execute any function. And what is the weights only option? It's an option in torch.load that completely re-implements how the unpickler handles like every bytecode instruction and aims to restrict what can be unpickled to the state dicts of NN module, optimizer, and LR scheduler. So what are the goals and non-goals here? The goals are we want to avoid remote code execution during torch.load. The non-goals are we're not trying to avoid resource exhaustion during torch.load, and we're also not trying to solve security concerns outside torch.load. Okay. So what are the like sort of rules that we want to abide by for this like re-implementation of the unpickler? We want the unpickler to, by default, only be able to execute a restricted set of functions that we have audited to be safe. The unpickler should not be allowed to import any modules. And any instance methods called recursively by the restricted set of functions should not be alterable by what is in the checkpoint. So for example, if the unpickler had rebuilt some object, object.setState should only be allowed if it's like the default tensor set state which we have audited. So I have a table here which goes over like all the pickle bytecode that we like allow and like what we do for each one, whether we categorize it as risky or not. But maybe first let me like briefly go over how like tensors and tensor subclasses are pickled to maybe like give a bit more context. Okay, so how tensors are pickled are that we implement this method called reduceX. What this method does is it returns a callable and a set of arguments. And when rebuilding the object, the callable will be called with this set of arguments. So for the default tensor path, it goes into like this part. And if you're using like a tensor subclass, it goes into this part where type self will be the type of the tensor subclass. So for example, like 2tensor. And these functions and classes will always be pushed onto the stack as what is called like a global instruction. And typically global instructions can import, so global instructions are followed by a module and like a name. So typically the global instruction would import the module and then it would like get adder and name from the module. So this could be like getting like 2tensor from like wherever 2tensor is defined, or getting like rebuilt from type v2 from where this is defined. So that's what a global instruction is. And yeah, so to give an example of what the bytecode looks like for a tensor subclass, you would push like rebuild from type v2, which is a global, and you push like rebuild wrapper subclass, you push 2tensor, etc., etc. So if for everything that's defined like in core, this is like not very problematic because we're able to like audit the code, audit the function that's used for rebuilding, audit the class, like we have access to the class, so we can put this in a predefined allow list. So instead, whenever the unpickler encounters a global instruction, it would convert the string that's associated with the global instruction via like a lookup in a predefined dictionary of like what we consider safe. And then similarly, any callable that's used to rebuild an object would also be from this predefined dictionary of safe globals. So when it comes to tensor subclasses that are like out of core or like certain other objects, we don't have the class, so we cannot allow list it. So we kind of need to have some process to like allow us to get the class in order to be able to rebuild it. And also we need to make sure that whatever code that is called when the tensor subclass is being rebuilt is like also restricted. Sorry, Jace, you had a question.
Is loading a tensor subclass in weights only, is that like fundamentally a non-safe thing though? Like, should that be allowed?
So the thesis that we're trying to put forth here is that rebuilding tensor subclasses, so there's two types of tensor subclasses, right? There's like wrapper subclass, non-wrapper subclass. And the thesis that we have is that if there are only a certain set of instance methods of the tensor subclass that will be called that could be called during the rebuild process. And we do not allow weights only to unpickle this tensor subclass by default unless none of these methods are overridden. So like the exact methods are these that are listed over here.
That makes sense. Sorry if I like jumped your punchline. This makes sense.
No, I think that was pretty much what I was building up to. Yeah, so I think this is like the main gist of what we're trying to do here. So like the dict that the allow list that's a dict, as well as like the tensor subclass part, where we only allow tensor subclasses if they don't override all these like things that we've defined that could be risky. And then one more piece here is like what happens if like a tensor subclass has to override this, like for example, like set state. So like what happens there? So we do have like a escape hatch over there, which is that we allow users to add globals to be safe and then like rerun like torch.load, and then that specific global will be allowed. So like for that, we count on the user to be like, I'm okay with this. Yeah, I'm okay with this function being run. And sorry, one part that I might have missed is that because we don't allow imports, so we also like expect users to import the library that contains the tensor subclass that they want to unpickle. Yeah. Are there questions?
I have a higher level question, which is I feel like I agree that this approach is like technically sound and you can get a safe system with it. And I just don't know, like, but are people still gonna not like it because there's a pickle involved and they're scared because there's pickle?
I think this is a valid point. Like people have the impression pickle's unsafe because it executes arbitrary code. I think like the other extreme of like trying to dispel this where we use pickle kind of thing is like the safe tensors route. But as for like my understanding of the safe tensors like status quo is that as of a few months ago, they were like, we don't want to add additional functionality into safe tensors. So like certain functionality that torch.load has, for example, like storage sharing between tensors will be preserved when loading, or like all this like tensor subclass related things would not be something that we can cover with safe tensors. Does that answer the question? Yeah. Are there any other questions maybe regarding tensor subclass? Because I know last week at Composability, there's a lot of discussion about tensor subclass serialization and like some gaps with it.
So, like if the tensor subclass is defined in Python, and if the runtime need to unpickle it, like we don't have the definition, right? So meaning like if any weights is a tensor subclass, and then we were to export it and then run it in a C++ inference system, we have to find another solution.
So just to clarify, this is in like the export context, right? So I'm kind of curious, like what is being done right now for tensor subclasses within export, as I'm not very familiar with that.
So far, we haven't seen tensor subclass in weight. I don't know, Chis or Joe have other example where like tensor subclass showing up in weight.
Yes, for church.
Yeah.
Yeah, I mean, Sherlock, from all the subclass inference docs I've seen, my understanding of what would happen here is that the same way we would desugar the subclass ahead of time, so that the exported graph would never contain subclass object or expected to have subclass object flowing through it. This will naturally make it so that the input to such a graph will also be plain tensors. And because these inputs are plain tensors, you basically don't hit that problem that we have here. So,
but
that
in
is
pre-dispatch graph, yeah, like after post-dispatch, after desugaring, we'll get rid of this. But in pre-dispatch graph, we might have cases like if weights are tensor subclass.
Right, and that is my understanding of how the document from Michael Suo was solving that, and why this document was explicitly asking for this ahead of time lowering paths to run, right? So you do your pre-dispatch export, you do whatever you want with that, then you have a Python lowering phase that basically does the AOT dispatch world, which is going to remove the subclass. And then you do get an IR that you can send to a C++ only object.
Okay.
Joel?
Oh, hi. Sorry if you covered this somewhere, but do we still need this fix, right? To pass along the dispatch related args to make wrapper subclass when reconstructing?
Are you referring to this issue? Yes, I think that these like still need to be fixed, and like the solution of like reading it off the class and like making sure that all this is compatible with weights only is, yes, something that needs to be done.
Okay, cool. Thanks.
Andres?
Another maybe dumb question. Albin, in the story you just painted so beautifully, when do you save the like model? I'm training, I save a checkpoint. I'm assuming it would be saved with tensor subclass. Like, yeah, how does the state pick need to get mutated to then be like post dispatch?
My understanding of how the export process works from, again, Michael Source, okay, I'm not saying I know that. My understanding from the question I asked there is I was told that the export process takes as input the whole model and is going to spit out the export IR that you can use in your C++ runtime and the packaged weights that you need to ship with them. So because the export process is also spitting out the updated weights, this is my understanding of why we can do that trick where even if the input weights are subclasses, the weights outputted by the export phase are going to be a different structure and plain tensors. But the export graph that you get will expect this new structure, yes.
Yeah, that makes total sense. Thanks.
And maybe this is implementation details of the thing that you're describing, but I know like one way we discussed doing that was with parameterizations as like a convenient way of like getting the desugaring.
Yeah.
And like very concretely, if we do it that way, then it wouldn't like, it almost wouldn't matter if you happen to be exporting for C++ or not. You would be like authoring your model via a parameterization such that like the state dict is already written in a way that does not have subclasses in it.
I am not sure we want to always recommend everyone uses parameterization. Like in particular, when autograd is involved, there is a semantic difference between the input of the parameterization being the thing the optimizer sees, or the output of the parameterization being what the optimizer sees.
Sure.
Yeah. So no, I think these two are semantically different from the user model point of view. So I don't think we should tell everyone to use reparameterization so that their state dict is always plain tensors only.
That makes sense. So I guess we only care about this in the C++ inference worlds, and parameterization is a convenient way to make that happen if you're doing C++ inference.
Yeah, I think parameterization in my head is just a convenient mental model on what export preprocessing can do on the module to get into that state, without them having to invent new custom logic to desugar the subclass into plain tensors. Like I think it's a relatively simple mental model of this is how you rework your module into something that you can just run your regular export system on.
Right, that makes sense.
But you do have to make this assumption that autograd will most likely not run anymore on that, and there is some small semantic differences.
Okay, we're out of time. Thank you, everyone.